Alright guys, we left off on doing the transition metal naming for ionic compounds. So this is where we just were. Moving on to polyatomic ion naming. So they're still ionic compounds and they're still just as simple as they have been. The only difference is now they're not simple ionic compounds, they're a little bit more complex. They have multiple elements instead of just having two, which is what binary means. Just some examples of polyatomic ions: NO3, SO4, etc. Remember, you have this list and you get to use the list on the test. Okay, so the first part of this is, again, identifying your metal, naming it. If it's a transition metal, we're still going to name it with a Roman numeral charge. Second element, we will still identify if it's a nonmetal, and if it's off the periodic table nonmetal, we change it into IDE. The only difference is if we have a polyatomic ion, we're going to name that polyatomic ion directly off our list. So here's an example. We have Na2CO3. Na2, we have CO3 as our polyatomic ion. The reason I know there's a polyatomic ion in this compound is I have three separate capital letters, N, C, and O. So I identified my polyatomic ion as CO3. I name my metal sodium. It's not a transition metal, so I just name it sodium. CO3 is carbonate, so I just name it as well. So this is just simply sodium carbonate. Okay. Next one, same thing. I have a polyatomic ion in this compound because, again, three capital letters, N, H, and C. What I'm going to do is put a parentheses around my polyatomic ion, which is NH4 in this case. Again, you can know that by looking for it on your polyatomic ion list. And then I can now identify it. NH4 is not a metal, but it is a polyatomic ion. So I'm going to use this rule right here, which says I just name my polyatomic ion. NH4 is ammonium, so I just name ammonium. Cl I treat like I have been, which is chlorine, so I change its ending to chloride. So ammonium chloride. Okay, same way when we are crossing and dropping these will work the same way. If I want to put calcium and chlorate together, ClO3 is chlorate, I use my charges, so I'm going to bring down the 2 and bring down the 1. And again, if you do what Mr. Akins and I have been telling you, which is just keep your polyatomic ions in a cage for right now, you won't have this issue. But anytime we bring down a number greater than 1 to a polyatomic ion, we have to put it in parentheses so we can understand that this is 2 chlorate, 2 ClO3s. Okay, and this of course would be C, calcium, Ca, calcium, ClO3, chlorate, calcium chlorate. Okay, so let's practice some. First off, again, identify if there's a polyatomic ion present. Here we have a capital N, capital H, capital C, capital O. So we've got 4 capital letters. We have a polyatomic ion. First step is to identify which one or which ones. In this case, we have NH4 and we have ClO3. NH4 is ammonium, so we name it. ClO3 is chlorate, so we name it. So this is, oops, sorry, let me fix that E. This is ammonium chlorate. Okay, next one, FeNO3 2. My polyatomic ion is already in parentheses, so that makes my life a little bit easier. Notice here we have a transition metal, so we have to name it like a transition metal, which means I'm going to uncross and unswap, bring up my charges. So I get Fe plus 2, NO3 minus 1. I check on my polyatomic ion list. Nitrate is supposed to be a negative 1. So now I just name it. Iron 2, NO3, nitrate. Next one, same thing, or same concept. I have Mg3PO4 2. Mg is magnesium. He is not a transition metal, so I just name him. PO4 is a polyatomic ion. I just name him as well. Whoops. Forgot the pH there. Sorry about that. Let's try that again. Phosphate. Okay. NH4 parentheses 2O. Already identified the polyatomic ion. NH4 is ammonium. Okay. O is oxide or oxygen. We name it oxide and we're done. Mn, transition metal. Bring up my charges. Okay, so I get Nn plus 3. C2H3O2, negative 1. This guy is acetate. He's supposed to be negative 1, so now we just name him. Manganese, 3. Okay, and I'm just going to enter down to write my second part of this. Oops, sorry, I'm about to write chloride. It's not chloride. C2H3O2 is acetate. So manganese 3 acetate. And the last one, Al is aluminum, not a transition metal. So I just write it. OH already in parentheses, so it's our polyatomic ion. OH is hydroxide. So aluminum hydroxide. Not too bad. Okay, so now working them backwards, doing the cross and swap. Sodium and phosphate. We have Na plus 1. Phosphate we find on our polyatomic ion list. The reason we know this is not phosphide is the ATE ending. Phosphide, IDE, would tell us periodic table. ATE or ITE tells us polyatomic ion list. So PO4 is our polyatomic ion. Cross and swap. Na3, PO4. And again, you can keep this in parentheses if it helps you see it. And sometimes it does. Remember, we cannot change the polyatomic ion, so we're not going to touch the 4. We're only messing with the charge itself. Okay, next one, same thing if we're writing it out. Aluminum is Al plus 3. Carbonate, CO3, negative 2. Let's just go ahead and put our polyatomic ion in parentheses just to help us see it. So again, we cannot mess with what's inside the parentheses. We're just going to grab the charge and bring it down. So we get Al2, CO3, 3. Okay, so let's try some of these. Beryllium nitrite. Beryllium is Be plus 2. Nitrite is NO2. NO2, negative 1. Cross and swap. Make sure you have your polyatomic ion in parentheses so you see it. Cross and swap. We get Be, NO2, 2. Okay, chromium 2 hydroxide. Chromium 2 tells us we have Cr plus 2. Hydroxide is OH. We'll put parentheses around him. Negative 1. Cross and swap. We get Cr1 OH2. Okay, and here you definitely need a parentheses. Make sure you have a parentheses around hydroxide with a number on the outside. Gallium is Ga. Whoops, sorry, let's rewrite that Ga. Ga plus 3. Chlorate is ClO3, negative 1. Cross and swap. We get Ga, ClO3, 3. Ammonium, NH4, it's a polyatomic ion, parentheses. Plus 1, carbonate, again, polyatomic ion, and again, I know it's a polyatomic ion because of these endings. Ide is one of the few. We do have cyanide and hydroxide that are polyatomic ions, so just be careful of that. Hydroxide you're not going to find on your periodic table, which tells you polyatomic ion. Carbonate is CO3, negative 2, again, parentheses. Cross and swap the 2 and the 1. We get NH4, parentheses, 2, and then CO3, 1. And zirconium 3 sulfate, Zr plus 3. Sulfate is SO4, negative 2. Cross and swap, Zr, well, looks like zinc. Let's try that again. Zr, SO4, 2. Okay, let's quickly just go look at all ionic compounds and let's see how we can do on these. First one, we have Na2CO3. We know we have a polyatomic ion here because we have 3 capital letters, the N, the C, and the O, so we name it like we would with a polyatomic ion. I'd go ahead and put the polyatomic ion in parentheses so we see it. Na is sodium, so we simply just say sodium. CO3, carbonate, directly off our polyatomic ion list. So this guy is just called sodium carbonate. KCl, again, potassium is just a general metal. Chlorine is just chloride. Okay. Iron is a transition metal, which means we need his charge, so uncross and unswap. We get Fe plus 2, chlorine minus 1. Chlorine's supposed to be a minus 1, iron's supposed to be a plus 2, so now we name this iron 2 chloride. Okay. Zinc, again, transition metal, but he's one of the transition metals we already know his charge, so we don't need to go through and identify his charge. We can just name him. Zinc is always 2, so that makes our life a little bit easier. So zinc, whoops, zinc is Zn is zinc, OH is hydroxide. So just zinc hydroxide. Chromium again is transition metal. Sorry, there's a couple transition metals on here. That's okay. Chromium's transition metal. I'm going to uncross and unswap. I get Cr plus 2. Fluorine minus 1. Fluorine is supposed to be minus 1, which means chromium is in fact a 2. So chromium 2 fluoride. Okay, lead again transition metal. Bring up my charges. So I get Pb plus 2. Sorry, Pb plus 1, there we go, oxygen minus 1. Now again, this is where we have to check our charges. Oxygen is not supposed to be a minus 1, it's supposed to be a minus 2. Well, if he's a 2, why is there no 2 in the compound? Well, that must mean lead is also a 2, and the 2's canceled out, which is why we have 2 1s. So when I cross and swap these 2's, they would simplify into 1s and would give me PbO. So now I name this lead 2 oxide. Now lead's not commonly in the transition metal group, but we treat it like a transition metal because it acts like a transition metal. Lead can have a plus 2 or a plus 4. So we do have to identify the charge still. Next one, Li3PO4. Li is just lithium. PO4 is phosphate. Okay, and you kind of get the basic gist of it. Let's work these backwards. Sodium is Na plus 1. Phosphide, notice the ending IDE tells me phosphorus minus 3. Cross and swap, Na3P. Magnesium is Mg plus 2. Nitrate, ATE ending tells me polyatomic ion, which is NO3 minus 1. Cross and swap, Mg, NO3, 2. Lead 2 sulfite, lead 2 tells me Pb. Oops, sorry. Let's try that again. Pb plus 2, sulfite is SO3 minus 2. Cross and swap, the 2's will simplify, but let's just look at that. We get Pb2, SO3, sorry, about to write a 4, 2. The 2's simplify into 1's. So we end up with Pb, SO3. Okay, ammonium sulfate, ammonium's polyatomic ion, it's NH4 with a plus 1 charge. Sorry, I'll go back to putting the polyatomic ions in parentheses. As sulfate is SO4, negative 2. Cross and swap, NH4, 2, SO4. Okay, and again, you'll get the basic gist of these. You just go through. My advice is don't skip any steps. Okay, so let's look at acids next.